We are live, you guys. So here it is, April 28th, 2020. We're still in confinement, but we're going to let this thing pass. We're going to be good. We're going to be back to normal, okay? So first of all, here's the things I want to talk about. First of all, incomplete. So if you are not, most of you guys are doing a great job. I'm so proud of most of you. But there's a few of you that are not doing their work, and they might not even be watching this film. But let them know, your friends know especially, that, yeah, we can give, or I can give an incomplete at the end of the year. So if you we can't give an F, but I can give an incomplete. So an incomplete means you haven't done your work. You'll have to make it up, whether or not you have to make up those individual units or whether or not you have to make up the whole entire course. All depends on how much you have been working. So if you are only missing a little bit, I can give you an incomplete. If you're missing a lot, you have to take the whole course over. That would suck. So make sure you tell your friends, or you guys make sure you continue to work and get the stuff into me, okay? All right, homework. Let's check your homework real quickly. I think you found this is pretty easy. Okay, so on page 227, here to go. Number 1, an octagon has 1,080 degrees. A 15-agon has 2,340 degrees. A 24-agon has 3,960 degrees. Number 4, it's a septagon or a heptagon. Those are the same figure. It's a 7-sided figure. Okay, 2 different names for the same thing. 15 is an undagon. 6 is an 18-agon. 7 has 155 degrees. 8 has 90 degrees. 9 has 140 degrees. And 10 has 20 degrees. So thank you again for showing all your work. You guys are doing a great job. Please show your work, okay? All right, so what are we going to talk about today? We're talking about parallelograms, okay? But before I talk about parallelograms, I want to talk about this concept about congruent. So I didn't have you in algebra, but in Algebra 1, before we do anything, let's talk about something called congruent. Okay, congruent figures. So we use this symbol here. That's congruent. Okay, now when you use congruent, it really is for figures, for shapes. So shapes can have the same size. Shapes can have the same size and equal measure. So let me give you an example, okay? Let me draw a little picture here. Okay, let's see, this is like there. Let's see, A, B, and I just drew it 3 centimeters. Let me draw a CD over here. Just want you to get this concept. This is before parallelograms, just a little review of algebra. 3 centimeters. Okay, so when you look at the two shapes, AB and CD have the exact same shape. So what we'd say is that AB is congruent to CD. And then we use equal only when we're talking about their lengths, because numbers. Equal has to do with numbers, okay? So when you see equal, has to do with length or measure, which is going to be a number, okay? Like a number. Okay, let's just review. So I can say that AB is equal to CD. These say 2 different things. They say the shapes look the same, they're the same size. They say that their measures are the same. They both equal 3. Okay, so that's congruent and equal. Just a small thing. But what are we really talking about today are parallelograms, okay? Parallelograms. Okay, so what is a parallelogram? Well, let's go straight to its definition, okay? So, definition. It is a quadrilateral, okay? Quadrilateral with 2 sets of opposite parallel sides. Okay? Alright. So, give you a second. Let's take a look at a parallelogram, okay? So, let me draw one down real quick. I want you to look at a parallelogram. We talk about its characteristics. So, alright, give me a second to draw a parallelogram. Let's see, 5. And I want to go 5 like this. Okay, here's my parallelogram. Boom, and boom. Not a perfect job, but you know, it's going to work, right? So let's label it A, B, C, D. Okay, so the definition tells me this. By the definition, I know that this side we use little arrows to show it, is parallel to this side, and this side is parallel to this side, okay? And I can just write that. See the arrows? So symbolize, I can say that AB is parallel, see that little symbol, parallel to CD, and I can also say that BC is parallel to AD. Okay, so parallel, see the little parallel symbol? Okay, that means parallel. Now, what else do we know? So parallelogram has several characteristics, okay? So first of all, so quadrilateral means four sides, right? Four sides. We know that. But because it's a parallelogram, it has several things that make it special. Okay, one, opposite sides are congruent. Okay, that means like AB is congruent, same length as CD, and we could say that BC is congruent to AD. Okay, same length. Okay, easy. That makes sense. Now let's mark it. Okay, I like to mark my figures, so I'm going to take my pen. I'm going to say that this side here is equal to this side here, and this side here is equal to this side here. I like to use my little symbols. Okay. Now, two. What else do we know? We know that opposite angles are congruent. So, for instance, I can say that angle A, let me use my pen, angle A is congruent to angle C, and angle B is congruent to angle D. So I'm going to say that. I'm going to say, okay, well, angle A is congruent to angle C, and I'm going to say that angle B is congruent to angle D. Alright, that seems obvious, hopefully. Now, third thing that you may not know is the diagonals bisect each other. Alright, let me draw on my diagonals. My diagonals are going to be these segments from corner to corner, vertex to vertex, okay? Here is a diagonal, and here's another diagonal. So, now look, they are not equal. That length in green is not equal to that, but what they do is they bisect. They cut each other in half. Chop each other in half. Okay? Let me put a middle point in here called D. So here's what I know. Now I know that if they bisect each other in half, I can say that AD is congruent to DC, and I know that BD is congruent to, oh, I had to put a D here. That should be E. Oh, my bad, you guys, my bad. AE to EC. Oh my goodness, early morning, huh? And I could say that AE, BE is congruent to EC. There we go, much better. Alright, diagonals bisect each other. So for instance, if this is 10, just imagine if this is 10, that's 5 and 5. If this is 6, that's 3 and 3, okay? And the fourth thing we're going to talk about is the fact that adjacent angles are supplementary. Okay, which means add to 180 degrees. Okay, so an example: if A was 60, B would be 120. They have to add up. If A was 80, B would have to be 180. I'm sorry, 100. If A is 80, B would have to be 100. If B is 100, C would have to be 80. If C was 80, D would have to be 100. So they have to add up to 180 degrees. Okay? Alright, so let's take a look at what we know. So example 1, pretty easy. So I know that if it's a parallelogram, then these two sides must be equal in these two sides. So if I have to find x and y, let's start with these two sides right here. Let's start with x plus 18 equals 3x minus 2. We'll just solve. Okay, minus x 18 equals 2x minus 2, plus 2 plus 2, 20 equals 2x. Divide by 2, x is 10. Okay, we've got x. Now to get y, just plug that back in. So 10 goes right into here, right? So since y is equal to 4x, and x is 10, then y has got to be 4 times 10, or 40. Hopefully that made sense, since they're equal, okay? Let's look at example 2. Okay, example 2. So I can't find x yet from here, but I can go to the angle, see, because I got y and x. So, you know, I've got x and y, and I can't find out what that is, but I can take a look at the angles. I know angle A is congruent to angle C, so I'm going to start right off with my 49 is equal to my 4x minus 37. Okay, let's solve for x. Plus 37 plus 37. Again, if I get going too fast, you guys just pause the video. Honestly, just pause it, okay? So 49 plus 37, I got an answer of 86. 86 equals 4x. Divide by 4, right? I get 21.5. Okay, that's x. And if I want to find y, let's just plug that into both sides. So I'm going to have a, let's see, let's take this and put it over here, slide over here. So I'll put this 4 times my 20, right here, show you I'm taking my 21.5, put it right there. So I go 4 times x, but x is 21.5, so put 21.5 there. Minus 3 equals 1/5 y, okay? Well, use my calculator. What is 4? What is 4 times 21.5? I don't know. Times 4, and I get 86. And then I'll subtract 3, so 86 minus 3 is 83 equals 1/5 x, or 1/5 y. And then to solve for y, I will just multiply by 5, because that'll cancel. 1/5 of 5 just cancels. What is 83 times 5? And my calculator says it's 415, so that's the value of y. Okay, got it. Moving on. So now they also want the value of DC. Well, that's easy. If 415, actually you already got it, because I think you got 83 for this side. Yeah, you got 83. So if this is 83, then this has got to be 83 also, because they're equal, right? This is 83. Just figured that out by plugging it in. All right. Okay, now turn the page. All right. Number 3. Oh, graphing. I like graphing. So find the coordinates of the intersection of the diagonals of this parallelogram. Okay, well, we'll do a little geometry. That's what we're in. 0, 0. There's point A. 1, 3. There's point B. 6, 4. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4. And then 5, 1, 2, 3, 4, 5, 1. Okay, that's C and that's D. Let me take a moment to connect the dots. Alright, okay. And I got that one. And I got that one. And I got that one. Here we go. I got my parallelogram just about drawn. Okay, now, the diagonals. Draw those in a different color, okay? Yeah, I'll use this color. So let's see, draw my diagonals. That's from A to C. And from B to D. And it sure looks like the point of intersection is right there at the point 1, 2, 3, 1, 2. At 3, 2 is the coordinate of the intersection between the two, okay? There we go, that was pretty easy. Number 4. Almost done. 4th point. So let's draw 1, 2, 3 of them. And that would leave me almost done. 1, 2, 3 points of parallelogram. We'll find that other point. So 1, negative 1. There's A. 0, 2. There's B. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. And there it is. C. There's technically 3 points. We'll go for the easiest one. Technically, in a parallelogram, you can have one way up here. Let's see, you could have one way over here. You really could. But the easiest one is the one that's probably right in here, okay? So here's what we know. Since it's a parallelogram, we have to have parallel sides. So I'm going to go and look at slope, okay? Show you how easy this is. So the slope from B to A is down 3 over 1, right? Down 3 over 1. So I'll do the same thing. From C to D, I'll go down 3 over 1. And that's got to be where the 4th point D is to make my parallelogram. You check this, up 2 over 4, up 2 over 4. There it is. So the coordinate of D is at 1, 2, 3, 4, 5, 1. Pretty easy assignment for today. Homework. Okay, homework. And again, show all your work. I expect you to show all your work. So we're going to do today, you guys are going to go to page, here it is, 232. You're going to go to page 232. We're going to go 1 through 11 all. Okay, have fun with that. Good luck. Make sure you show your work, please.